Have you ever, like, stared at a math problem and it feels less like you're solving something and more like you are building a puzzle that someone else designed?
Uh-huh. Yeah, I know that feeling.
Well, that's exactly what we're diving into today.
Oh, cool.
Yeah. The big question, is math something, like, out there in the universe just, like, waiting to be discovered?
Mm-hmm.
Or is it something that we humans just, cooked up?
It's a question that's been debated for centuries.
Yeah, for sure. So to, like, really get into this, we're going to be digging into some excerpts from this text called math-discovered-invented.txt.
Catchy title.
Right. And it jumps right into this debate. And one of the first things that, like, really caught my eye reading through it is this idea that math has quirks.
Quirks.
Yeah, like flaws. Even it calls them funny artifacts like infinity.
Infinity. Always a head scratcher.
Yeah. And it kind of blew my mind because, I always thought of math as this perfect system, right? Like unbreakable.
Right. It seems so absolute.
Totally. But then you hear about stuff like, different sizes of infinity.
Whoa. Yeah. And it's like, wait, what?
It's not just one concept, right?
Yeah.
You've got countable infinity. You've got uncountable infinity.
It's like someone just pulled the rug out from under you.
It gets pretty wild.
Yeah. Tell me about it. I'm starting to feel like I need to go back to elementary school and relearn everything. But okay, so getting back to this text, it talks about these what it calls shaky foundations of math.
Okay.
Can you break that down for us?
Sure. So basically, we humans created math, to describe the world around us, to understand it. We built it up, definition by definition, theorem by theorem.
Mm-hmm.
But the thing is, those building blocks, those basic concepts, they're ultimately based on our perception of reality.
Okay, I see where you're going with this.
And perception, as we all know, can be, well, a little flawed. Subjective.
For sure. So, okay, if math is like a human construct, does that mean it's automatically an invention and not a discovery?
Because humans also invented, I don't know, the wheel, but circles existed before we figured out how to roll things on them, right?
That's a great point. It's a really subtle distinction.
Yeah.
Think about it this way, okay? Imagine you're looking at a mathematical equation. You see all these symbols on the page, this mathematical language. That's all just a representation. It's a tool that we've created.
Okay, I'm following.
It's like a map.
A map.
Yeah. A map can guide you through a city, but it's not the city itself, right? It's a human-made tool to help us understand something much larger and more complex.
Oh, I like that. So, the equation isn't reality. It's the map to reality.
Right.
And the map, in this case, is definitely an invention.
Exactly.
Okay, that makes a lot of sense. Now, there's this other thing the text mentions that I thought was really interesting. It says that math evolved because it was useful. Like, if it wasn't a good tool for describing and predicting things, we probably wouldn't be using it right.
Exactly. It's all about practicality. Think about it. The ancient Egyptians, they used geometry for land surveying after the Nile floods.
Oh, right.
Or the development of calculus, to understand motion and change.
Mm-hmm.
That led to some pretty amazing things like, putting a person on the moon.
It's incredible when you think about it.
Math has always been driven by this need to solve problems, to make sense of the world, to reach for the stars even.
It's like this constantly evolving toolbox.
Exactly.
And speaking of tools, there was this one analogy in the text that really just hit me. It said, math is like a cathedral that we have to build before it can exist.
Oh.
It makes math sound so much grander than just, numbers on a page.
It really is a powerful image. A cathedral doesn't just pop into existence fully formed, right?
Right.
It takes a lot of planning, a lot of design. You've got generations of builders, carefully adding their stones to the structure.
Yeah.
And math is similar in a way. We might envision these grand concepts, these elegant theories, but they only really exist within the framework that we've created.
So you're saying that maybe, if those early mathematicians had laid a different foundation, the whole cathedral of math would look totally different today.
It's entirely possible.
Wow. I'm trying to picture Gothic math versus Romanesque math. Would we even recognize it as math?
That's a really interesting question. And it kind of brings us to another point the text raises. There's this tendency sometimes to equate math with the very fabric of reality itself. You hear people say things like, the universe is made of math.
Yeah.
But those phrases, as the text argues, can be a little misleading. It's like saying the map is the territory. But you can't walk on a map, right?
Exactly.
There's a difference between the representation and the thing itself.
Okay, so the text is kind of pushing back against those big sweeping statements about math being the ultimate truth of the universe.
In a way, yeah.
And it takes us even further by bringing up this idea of the sociology of mathematics,
Interesting.
which I gotta admit I'd never even thought about before.
Right. It's not something you typically hear about in math class.
Definitely not. So what's the deal with this whole sociology of math thing?
Yeah. Well, it's all about how mathematical knowledge is actually shaped by the community of mathematicians.
Okay.
You see, mathematical concepts, they're not just handed down from on high, from some mathematical Mount Olympus.
Oh, right.
They're rebated, they're challenged, they're refined through a process of collaboration and consensus. Even something as fundamental as zero was a topic of debate for centuries.
Really? I never knew that.
Yeah. And you imagine a world where zero wasn't a thing.
That's wild.
It really makes you realize how even the most basic elements of math are, in a way, built by people through this ongoing conversation.
Okay, I think after this deep dive, I'm starting to see this whole invention versus discovery debate in a whole new light. It's not just about, whether numbers were floating around in space before the Big Bang. It's about the fact that we humans, with all our flaws, all our biases, and all our brilliant ideas, created this system, this language, this way of understanding the universe.
And it's a system that's constantly evolving. It's open to new interpretations, new possibilities.
Which leads us to this mind-blowing question, the one the text leaves us with. If math is invented, does that mean we could, invent entirely different systems of math?
Whoa.
What would those look like?
Yeah, what kind of universe would they reveal to us?
I don't know about you, but I'm feeling a lot less intimidated by math now and a lot more excited by it. There's a whole universe of possibilities out there just waiting to be explored.
Maybe even built.
Right. Thanks for diving deep with us today. And, keep questioning.
Absolutely.
That's how we learn and grow.
Couldn't agree more.